Howdy! In this video, we're going to look at rational exponents and how they relate to radicals. So we'll convert fractional exponents into radicals in order to evaluate some numbers, and then we'll also look at how to convert radicals into rational exponents. All right, so to start, this is the definition of a to the 1 over nth power, right? If you have a number to a fractional exponent, we can rewrite that as the nth root of a. And you might wonder, why? Why are we allowed to do that, right? So here's what we're going to do. We're going to rewrite that equation right here just to explain why a to the 1 over nth power is the same as the nth root of a. And what I'm going to do is suppose it's true, and then you'll see that, oh, it does work. Okay, so a little bit backwards as far as proofs go. This is not a formal proof, right? But what I'm going to do is raise both sides of this equation to the same power. That power is n. So a to the 1 over n to the power of n, let's see what happens, right? We're going to suppose it's true and see what happens, okay? And the nth root of a to the power of n. All right, so a to the 1 over n to the nth power, well, we would multiply those exponents by exponent properties, and 1 over n times n is 1. I'm actually going to delete that and just write a to the 1, right? And then here, the nth root and the n cancel. Now, if a is positive, let's suppose a has to be, we are going to make that part of our definition here. As long as a is positive, those cancel and we just get a, right? A to the power of 1 is, in fact, a. That's the same thing. So you can see that, hey, it checks out. That is true, okay? Now, let's get a little bit more advanced. Let's go ahead and look at what if you have a numerator, not just 1, right? But what if you have a to the power of m over n? So there's two ways to write it. For any rational expression, m over n, in lowest terms, meaning that fraction is fully reduced, where m and n are integers, and n is positive, meaning we're going to take the index has to be positive, square root, cubed root, something like that, right? We can rewrite a number to a fractional exponent, m over n. So a to the m over n, we can rewrite it as the nth root of a all to the power of m, right? That's because m over n, we can separate. If you're kind of wondering here, I'll do it scratch work here. M over n, we can separate that's that exponent there, as 1 over n times m. So when we have a to that power and a to that power, maybe I can move my little equal sign down a little bit. Right, there we go. Okay. Then by exponent properties, we could kind of unsimplify this, right? But write it as a to the 1 over n all to the power of m, which is exactly that. The nth root of a is a to the 1 over n, and then it's to the mth power. So anyways, that's just the reasoning behind it, right? But it really doesn't matter if you take the root first and then raise it to the power of m, or if you take raise it to the power of m first and then take the root. They're both, you get the same answer either way. So you could also write it as the nth root of a to the power of m. Those are equivalent, okay? So two different ways to write that. All right, so let's use this to simplify a couple of expressions here. Okay, so first thing we're going to do is simplify, or find the value of, I should say, 4 to the power of 1/2. And the goal here in this video is to do it without a calculator, okay? By converting to roots. So 4 to the power of 1/2, that means, if we convert it to a root, that means square root. Now, I said the 2 goes in the hook, right? The denominator goes into the hook. That's according to this property right here. N right here is the denominator, notice, and it goes into the hook of the radical. That is your index, okay? And the numerator is your exponent. So that 2 goes into the it is the index. It goes into the root, right? So square root of 4, right? We usually don't write the little 2 when we do square roots. People just leave it off. So square root of 4, you can write it like that if you want. On the iPhone, it actually has the 2 if you look at your calculator on the iPhone. But anyway, square root of 4, we know is 2. All right, now I'd encourage you to pause the video and try the next 2 without me. All right, now let's rewrite 8 to the 2/3 as a radical so that we can evaluate it in our heads, right? Because if you say, what is 8 to the power of 2/3, right? That's kind of, what does that even mean, right? I can do 8 squared, but we can do 8 squared, we can do the cubed root of 8. We can do both of those. So that's what we're going to do, is we're going to convert it into a radical. So that denominator becomes the index. So it is cubed root of 8 squared. Now, these numbers are small enough, you can probably do 8 squared and say, hey, that's 64, and then figure out the cube root of 64. But if those numbers are a little large, or if these numbers were bigger, that might be a hard way to do this problem. So what we're going to do instead is pull the 2 out. And we're going to first find the cubed root of 8 and then square that. The reason why is because we can find the cubed root of 8, right? The cubed root of 8 is just 2. And then 2 squared is 4. So that's an easier way to do it. All right, next we have 25 to the power of negative 1/3. What does that mean? That means, well, if you have a negative exponent, by exponent properties, that means 1 over 125 to the positive 1/3 value. So you just, that negative becomes positive when you move that into the denominator, okay? And now cubed root of 125, well, I mean, 125 to the 1/3 power is the cubed root of 125. So let's rewrite it as such. And then hopefully you recognize that, hey, the cubed root of 125, you say, what number times itself 3 times is 125? The answer is 5, right? 5 squared is 25. 25 times 5 is 125. So kind of thinking of 5 quarters, right? So anyways, cubed root of 125 is 5. We get 1/5. So we just evaluated 125 to the power of negative 1/3 without a calculator fairly easily. All right, next we have the next 3 have radicals and variables. And what we're going to do is simplify those expressions by converting them into rational exponents, okay? So 1 over the cubed root of x to the 4th. Let's rewrite it with as x to a power, okay? So there's a couple ways to do that, right? But first what we're going to do is keep it in the denominator and write the cubed root of x to the 4th as x to the power of the 4 becomes the numerator of the rational exponent, and that 3 in the index becomes the denominator. So 1 over x to the positive 4/3. Well, let's just say maybe that's what you want. Maybe that's fine for your answer. But let's say maybe you're in calculus and you need negative exponents because you're doing derivatives and that's easier, or integrals and that's easier, right? So let's write it as x to a power. Well, we can bring that x up into a numerator and call it x to the negative 4/3. And you could write over 1, but we'll skip that. All right, last we have an interesting one, the square root of x, the square root of x times the square root of x, right? A little bit different there. So what we're going to do is simplify it by converting it into exponents. So let's do both square roots, right? A square root, remember, it has a 2 in the hook. So it is equivalent to, both of them do, it is equivalent to a 1/2 power exponent. So this whole big root on the outside is a 1/2 power. So we have x times the square root of x to the 1/2, but I'm also going to convert the inside square root of x to a power of 1/2, right? So we really have parentheses x times x to the 1/2, but all of that is to the 1/2 power. Now, by doing it like this, we can use exponent properties to simplify that expression there, okay? So let's first combine the 2 inside. That is a multiplication there. It looks a little silly. Let's try that again. So times dot, there we go. All right, let's multiply. Now, the implied exponent on the first x is just 1. So we have x to the 1 times x to the 1/2. That is, well, 1 plus 1/2 is 3/2. So x to the 3/2. And that is all to the power of 1/2. And okay, now we want to simplify this. So x to the 3/2 to the 1/2, we would multiply those exponents by exponent properties. 3/2 times 1/2, we multiply the numerators, 3 times 1 to get 3, and the denominators, 2 times 2 to get 4. So that's a different way to write that same expression, but with rational exponents. And last, let's look at 2 times the square root of x, all times 3 times the cubed root of x. So we have a square root and a cubed root, and normally we wouldn't really mix those too much. However, they have the exact same thing inside, x and x. So we can write them with rational exponents and combine them. Okay, now order in which we multiply doesn't matter. We're really just multiplying the number 2 times the square root of x times the number 3 times the cubed root of x, right? So the two numbers can just be multiplied together. So we can just start by saying, hey, 2 times 3 is just 6. In other words, what I'm saying is those little parentheses are really just kind of unnecessary. They're not really doing anything. So let's reorder it, put the numbers together and put the x's together. As I put the x's together, let's write each one with an exponent. So that square root of x becomes x to the power of 1/2. And that's that one, right? And then this one here, the cubed root of x becomes x to the power of 1/3. Okay. How do we combine those? Same base, different exponents, and we're multiplying. So by exponent properties, we will add. Let's write it out. We've got 1/2 plus a third. Now, if you are good with fractions in your head, you can probably do that, but let's do some scratch work here in case you're a little rusty. 1/2 plus a third, we need a common denominator, which would be 6. So 1/2 we can rewrite as 3/6. 1/3 we can rewrite as 2/6. Then 3/6 plus 2/6 does make 5/6. So in short, this becomes 6 times x to the power of 5/6. And that's all for this video on radicals.